My name's Ed. I'm the author of Buildbarn. Today I'm going to talk about a project that's hosted underneath GitHub / Buildbarn. Until recently, it was called DB Playground. That was sort of like it's somewhat intentional, vague name because it was back at the time a bit of it was a true playground, but I also didn't want to like give any sort of false expectations of what it was, so I chose a generic name. So nowadays it's called Bonanza. First, like before actually talking about what Bonanza is, I want to share my thoughts on Bazel. Right, I've been using it for a couple of years. When I think of Bazel, I sort of have to think of this, right? So there in the middle, it's Bazel. It has to make a decision like, do I stay on the dock or do I get on the boat, right? And with that, I mean is like, there are quite a lot of things in Bazel where they could do something in a really awesome way or in a really traditional way or like a complex way or simple way, and they sort of choose the middle ground, right? The place you don't want to be. And one of those things is, for example, right out of the box experience and reproducible behavior, right? For example, run Bazel on a Mac, and it will automatically figure out which copies of Xcode you have installed and use that. But at the same time, you also want to have reproducible behavior. So, you run on different Macs, you run Bazel, you sort of get different results, right? It's and it's with like a whole bunch of things that it automatically picks up certain things from your host system, which means that even though it's supposed to be a hermetic build system, there's success is not guaranteed, right? Same thing with like local execution and remote execution, where there is sort of support for sandboxing when doing local execution, but that sandboxing isn't perfect. So then if you do remote execution, the sandboxing is better, but also done in a different way. So then you're sort of constantly dealing with, hey, it works on my machine when I run it locally, but then if I use remote execution, it still breaks, or the other way around. It's a bit of both, and the Bazel developers can't really seem to like, focus on just making one thing work well. Like it has to do it all. It leads to sort of this massive complexity. And then also this other thing that I see with Bazel is, Google has its own sort of requirements for like keeping it all up and running and making sure that like the internal use case of Blaze isn't affected. And on the other hand, there's also all these, features that are being requested by the OSS community. For example, the C++ rules are like a really good example of that, right? Where what they did is they, there was a copy there was a version of Bazel, like when it came out, that you could write your rules in Starlark. At the same time, there were these integrated C++ rules. And instead of just saying like, okay, let's just keep the Java version of rules to ourselves and just do a clean slate implementation of like a simpler version of the C++ rules for general consumption externally, right? One that doesn't support feedback-driven optimization and blah, 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 but just one, the only thing it does is just cc-o and compile something, right? And write that in pure Starlark. That would have been good enough, but instead, we as a community had to sort of deal with like the sort of the legacy use case sort of, whereas we as a community most likely just wanted to have a simple Starlark implementation. We could just take it from there, right? So, I still think that Bazel's like the best build system out there. This is not supposed to be like talk where I completely sort of dunk on Bazel. It's a really good system, right? But still, I think that there is something that we sort of can do better, especially for sort of like power users, people who use Bazel to large scale, large enterprises. So the last couple of months, I've been doing an experiment. Started working on this in September. And what I have, I'm not really sure whether it's at this point better than what Bazel is. It's absolutely not. But it's sort of like, a bit of an experiment to sort of see what's all possible, where what we could do if we sort of like, didn't just look at Bazel, but, did whatever we wanted, right? Or whatever I want. Maybe that's a better way of phrasing. So I wrote this sort of experimental build system called Bonanza. And what it can do is it can only do remote execution. So really, there's no support for local execution, right? So obviously this can be a bit annoying because if you want to debug something, blah, blah, blah. Obviously there should be features for like maybe replaying an action locally, right? Where you can sort of say this thing failed remotely, but hey, now I just want to run it locally with GDB attached or something, right? But there shouldn't necessarily be support for actually like as part of the Bazel build, do something locally, right? Another thing it also does remotely is the analysis. This currently happens locally in your own system. So you've got like a poor laptop with only a couple of gigs of RAM and 100 Chrome tabs open. And then your system runs out of memory, right? Where you need to tell people like, yeah, if you want to build // ... you must run Bazel with -- host args x mx x. I don't even know what the spelling of the flag is, but the one that increased the memory limit. The same thing with repo rules, they'll run locally. Yesterday I checked. So the BB storage repo when cloned, the git checkout like 12 megabytes. But if you just do Bazel build // the externals directory for that build is 2.5 gigabytes. So like there's 200 times as much stuff that needs to be downloaded from the internet as what BB storage actually is, right? And that's really annoying. Like I've seen projects where if you attempted to sort of do like a Bazel build // with remote download minimal, you'd still use like 100 gigabytes of disk space, right? For all the stuff that would get downloaded. So that also needs to happen remotely. One of the things I also wanted to sort of experiment with in Bonanza is making use of encryption. So, especially if you sort of have like a multi-tenant cluster. Right now you can use instance names and that kind of stuff to sort of add this access controls and partitioning of data so that people can't look at each other's data. But that still means that the operators of the storage cluster can just, easily just scan through the cache and see everything. And, you sort of have to rely on the security ACLs to be correct, right? But if you were to just be able to sort of use encryption, where you sort of say like, yeah, there's a key that the workers can use and the client has, but the storage nodes don't, then who cares? You're just like storing random garbage, right? That's the idea behind BB against Bonanza, right? Another thing is I only want to be able to sort of support Starlark rules. But one of the things I didn't want to do is create like a completely new build system that was incompatible with the rest, right? So for example, again, I fully understand like why they did it, but for example, take Bug 2, right? It's Facebook wrote it, and they're obviously having like a lot of fun with it, and they released it as open source software. But the fact that it uses a different rules API means that I think it's unlikely that there's ever going to be any general adoption of that tool, right? Nobody is interested in writing yet another rules Go in Starlark that has the same set of features for just to sort of make it run on Bug. So Bazel compatibility is pretty important. So in the next couple of slides, I sort of want to show you sort of, we'll run through what like running a build with Bonanza looks like, and then there's lots of sort of topics we can talk about, or I can talk about like how I implemented it and what's sort of different about it compared to Bazel. So let's try to kick off a build. So here in this picture in the bottom left, you see that there's a CLI, unfortunately like a bit small, but you just run a Bonanza Bazel build, right? There's a CLI out there called Bonanza Bazel, and it tries to be sort of compatible with the Bazel CLI, taking the same set of flags, Bazel RC, that kind of stuff. And you can just build targets using the same patterns as what you normally have. What's different about this version is that it doesn't actually analyze the source code at all locally. It just takes your source tree, dumps it all in the cache, right? That's all it sort of does. And generally speaking, that's pretty fast because, especially if multiple people work on the same project, all of that data in your source tree already happens to be there, right? So it'll just run quickly. One big difference between this architecture and like what Buildbarn has is you can sort of see on the right-hand side, there's different storage nodes. Like, what's the difference? Why are these storage nodes different? So so storage architecture. So whereas with Buildbarn, you've got like front-end processes and storage processes, and it's all the same binary. It's just that the storage config is different. There's actually like a true difference between the front ends in the case of Bonanza compared to what Buildbarn is. And it's not the same. It's not the same as the actual backend storage. The reason being is that like the individual storage nodes that actually store the data, that's the shards, it's a flat key value store, right? You can just dump objects in it, and it's sort of similar to BB storage. But those front-end processes, they actually sort of have like a graph-based API on top of it. So, whenever you want to like upload a graph, you're not like just giving it individual objects. You're simply saying like, hey, I've got this graph. Let's work together to exchange the data that's missing, right? So clients, they need to sort of give the graph in a top-down fashion, but then the storage will flush it in a bottom-up way. So you know that graphs are sort of always complete, right? You don't have this problem with RAV2 where it's just a flat namespace, some of the stuff might be present and links to each other, but you don't even know whether stuff's complete. And this turns out to be like very bandwidth efficient, whereas Bazel often just needs to issue these requests against storage, like, hey, do you have like these 100,000 files? And then the cluster said, yeah, thanks for giving me these 100,000 SHA-sums, but only 5 of them were missing. You no longer have that issue. So the nice thing about this is it makes the protocol like a lot more efficient, but it also means you don't need like a find missing blobs like thing that RFV2 has, which currently makes it pretty hard to, for example, have a cache that's directly backed by an S3 bucket. Right? So yeah, here's sort of like a picture of what it works like. Hey, you have this graph. Yeah, I already have it, so you don't need to do anything. It's like literally 100 bytes of traffic, right? But then, whenever part of a graph is missing, there's sort of like this back and forth protocol where, there's sort of a nice parallel protocol for just exchanging this data. So one very big difference, like in the storage model, is that like with RFV2, cache objects are just plain data, right? There could be a directory, a file. There's no difference between a directory object and a file that happens to have the contents that are a protobuf message of a directory, right? But in Bonanza, it's an actual difference because like objects, they have a data payload and a set of outgoing references. So the storage is actually like aware of graphs. The nice thing is that data payload, the storage nodes don't do anything with it at all, meaning that you can actually just safely encrypt this data, and then the storage is still aware of like the graph structure of the actual data and be able to sort of ensure that sort of graphs of data, which could be like, directories with output files or like all of the information pertaining to a single build remains present, right? Even when compressed and encrypted. And there's like a bunch of sort of extensions to how objects are being identified. So normally in RFV2, it's always a SHA-sum and a size identifies an object, right? But in Bonanza, it's there are like a couple of extra sort of added fields, and the most important ones are the number, like the height of the object, and the bottom one, max size of path to leaf, which is sort of like the worst case you can have, like when you're at the top of the graph and you would walk to like a bottom of a graph, of how many bytes of data you need to sort of download from storage. And with these two metrics, I noticed, these two values added to it, I noticed that like you can make some really good algorithms for doing like really fast replication of this data in a way that's just completely parallel, but also guarantees that memory usage is being bounded, etc. So like, this with RFV2, where like, so the overhead of having this sort of back and forth, going back and forth and trying to replicate a graph, like, hey, do you have this part of the graph and whatever? Because you can all run it in parallel, it's still fast, right? So, this was a really good addition. So, here's sort of like a practical sort of view of what these objects then look like, right? Say if you want to model a directory of files inside of Bonanza. So normally, if you take a look at RFV2, it's the case that you've got like a protobuf message and it contains individual SHA-sums of the files, right? But we can no longer do this because the references, they need to be sort of, they're stored separately. They're no longer being stored as part of the protobuf message. So you see that we sort of make some, we have to jump through a bit more hoops, where if we have a directory in Bonanza that like, in the protobuf message, we basically store the index number of the reference, right? And then the reference is essentially just stored at the leading part of the object, and that actually points to the object in storage. So this is how we make it possible to like actually encrypt directories without having the storage be like unable to sort of walk the graph and essentially ensure that it stays in storage. Yeah. So enough about storage. Now we just want to kick off a build, right? So your source trees are uploaded to storage, and now we want to run the build. So there's a couple of extra processes that sort of get used there. One of them is Bonanza Scheduler, and the other one is Bonanza Builder, right? And Bonanza Scheduler, the name sounds quite familiar, right? It's essentially just BB Scheduler, but it's adjusted in such a way that it can deal with also traffic getting pushed through it being encrypted, right? So what you could do is you could just now at this point offer storage and scheduler as a service, right? That could just all get run by this untrusted party, which in my opinion are often like the hardest parts to sort of get working reliably, right? Because if the scheduler needs to be always online, otherwise all of the actions get interrupted in storage while you can't lose any data. You make it possible for people to just bring their own workers, right? And only manage that instead of managing like the storage and scheduler. And by adding this encryption, I noticed something interesting where the scheduler is now suddenly capable of scheduling arbitrary stuff. It's not just like build actions that you can send through it. It's just a generic scheduling system because the scheduler can't even take a look at what's running in there. So all this work that we currently did in the Bazel ecosystem to have like a separate protocol, like the remote asset API for essentially running downloads of files remotely. This is something that's now suddenly trivially implemented on top of this protocol, right? So also in the domain of hardware testing, this is kind of interesting with a use case that I had previously where we tried to do hardware testing via the existing remote execution protocol. Was that you can't really do hardware testing via remote execution. The best thing that you can do is you can schedule an action that runs on a computer that's running next to the hardware being tested, right? So we'll have a Python script getting executed via remote execution that runs on a Linux box somewhere that's hooked up to the embedded hardware. But that's also sometimes not desirable because that means that you've got like, a lot of cache busting, right? And anytime, for example, you bump the version of the Python interpreter, you need to rerun all the hardware tests. Or it might simply not be desirable from like a security perspective because you're essentially just giving people, access to run arbitrary stuff on an arbitrary computer. And it's even worse if that embedded hardware even like requires sudo access to access certain character devices for programming it. So you might even be giving like root access to a certain extent just for the sake of hardware testing. But with this system, you can just design your own sort of mini protocols for what a hardware test is, right? So that you say like, I've got a protobuf message that says this is the image that needs to be flashed. This is how EEPROM values need to be set, and this is what comes out of it, which is sort of a nice feature. Right. And now Bonanza Builder. And Bonanza Builder, this is the actual part that does the Bazel build, so to speak. This is the software that parses the build files, runs through the .bzl files that have been uploaded in storage, and it determines what needs to get built, right? This is essentially like what the Bazel binary does, but then running on your cluster. And this one receives the decryption key for like actually reading the files, and only as part of like the analysis it has this key, so when the build is over it no longer has the key, right? This process is completely isolated from the host environment / file system. So even though you're running this process on a Linux box, Bonanza Builder doesn't know it's a Bazel running on Linux, right? Why is that? It will call into the scheduler again whenever it needs to launch processes. So for example, for remote execution, that's already the case, just, CTX actions run, that runs remotely. But what it also does, it runs repo rules remotely, right? So those can now get run on remote execution workers. So this is sort of like a sort of more complete diagram. You see that Bonanza Builder, both connects to the scheduler to sort of pick up builds that need to be run, but it also talks to the scheduler to schedule the execution of individual build actions or actions running as part of repo rules. So now Bonanza Worker, like another component that shows up, it's sort of based on BB Worker, but it uses like the new sort of storage and remote execution related APIs. We have to make like a bunch of extensions to it to sort of make execution of repo rules work, right? Because repo rules have like a couple of very interesting properties. First of all, the input roots of them might be just huge, right? And there's also a lot of data that needs to be captured because normally you've got like a C++ action that might bring in like a C++ toolchain and a couple of C files or something like that. But it only has a single output, namely foo.o. So, that part uploading outputs, that doesn't really need to be that optimized, so to speak, right? You just upload a single O file and call it a day. But in this case, it might be the case that someone wrote a repo rule that does a git clone of this huge repo, and then we upload that thing into storage, and then there's like a follow-up, execute action in the repo rule that says like, oh, by the way, you need to apply this patch, or you need to remove this file from this repo. And then we need to generate we need to recompute a Merkle tree for like the same thing, but it's like 99% identical to the original one, right? And we don't want to like recompute the entire Merkle tree like that. For every patch you want to apply to the source tree, that it needs to recompute this 1 gigabyte Merkle tree. So we made some huge optimizations there to reuse parts from the Merkle tree as much as possible, and only actually rebuild parts that have changed. Another thing is like the stable input root paths. So Whereas normal build actions, they can generally be run at arbitrary working directories. So, and that's also what Buildbarn does, right? You see the SHA-SUM getting sort of splat into the path names whenever it does something via remote execution. That's something that Buildbarn does because it also allows it to run multiple actions in parallel, right? Especially if you don't have C groups, containers, something like that in place, you still want, like on a certain box, you want to run, say, dozens of actions in parallel. And to make that work, all those actions need to run in separate working directories. And this is something that we can't do for repo rules because Bazel's repo rules API like makes some really hard assumptions about absolute working directories, right? It assumes that this thing, like this repo that's being constructed is somewhere under /temp/Bazel/ blah, 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 /external/ something. And it can't be anywhere else. And if you run multiple commands as part of a repo rule, that thing can't just shift around. It's even like in the Starlark API for repo rules that like absolute paths are a thing. So, made an extension to the workers where like the Bonanza builder can sort of say like, oh, wait, hold on, this is a repo rule action. This must always run at the same location. So worker, you better make sure to do that. And, that will break concurrency, right? Because it means that in certain environments where you don't have containers, you can't run multiple such actions in parallel, but should be good enough considering that repo rules are generally not things that are sort of most executed. So with all these optimizations in place, I unfortunately had to drop support for non-fuse NFS v4. Patches are welcome. Yeah. So enough about like workers. Let's talk a bit more about the evaluation framework. So Bazel has an evaluation framework called Skyframe, and the idea behind Skyframe is that they just reuse any sort of word that you see in programming language and they put the word sky in front of it, right? So you've got sky variables, sky loops, sky, no, just kidding. You only have 3 of them, sky key, sky keys, which you can give to sky functions, and those then yield sky values. That's the idea behind Skyframe, right? So a sky key could be SHA-SUM of, or SHA-SUM of a file, and then you run it through a function that is like a file SHA-SUM computer, and out of it comes the SHA-SUM of that file, right? That's the idea. So one very big difference between Bazel's model and Bonanza Builder is that sky keys and sky values are always protobuf messages, right? And this is pretty awesome because it makes it all human readable, right? You can actually sort of walk through the build and for each of those functions actually easily read what goes in there and what comes out, right? Please configure this target, and you see a target name, and then out of it comes a protobuf message that actually shows you the contents of the default info provider that you can sort of click through, which is like pretty awesome. But the awesome thing is it can also be backed by storage, and then you have a shared analysis cache, right? Whereas, in Bazel, it's incredibly hard because inside of Bazel, sky keys and sky values, they're all native Java types. And it's not like a guarantee, like necessarily possible that those are all serializable and deserializable, right? That could even just have like cyclic graphs in them and that kind of stuff. So, but in this case, it's all protobuf messages. So that means that like even for like the silliest things, for example, parsing a .bzl file and then getting all the identifiers out of it. All of that is being stored in protobuf messages and just dumped. So even Starlark values like depth sets and all the kind of stuff all gets written to storage and can therefore be inspected, right? So I hope that at some point we can sort of have like a BB browser page, sort of less ugly, hopefully designed by Trey, that allows us to sort of like click through the entire build and actually sort of inspect everything, right? That you sort of have like a Bazel query that's not like a silly command line tool that prints some crap in your terminal, but it is just like a nice web UI that you can actually use to sort of explore and yeah. And it also means that you don't really need a sort of like a build event stream anymore, right? It's kind of interesting how Bazel, has all this logic for emitting like a 1 gigabyte JSON file and then uploading it to storage. Whereas if we had like an actual sort of storage-backed sort of analysis system, all of this data would already be explorable and more and easier to cross-reference. So my plan is to not add support for a Bazel build event stream to this, right? At least I hope I don't need to revisit that in 5 or 10 years, and you folks are going to call me out on that. So here's like some examples of what a Sky function essentially looks like. So there's a function called canonical repo name. And what it does is whenever you say like @foo, it needs to resolve it to the @foo of that thing, right? That's because that's how Bazel works. You've got apparent repos, and canonical repos. And like the canonical repo is, well, as the name implies, a unique name for to sort of identify a repo as part of Bazel's analysis. And an apparent repo is what you, as an author of a build file, use to refer to something. So if you say @rules go / whatever, that's not necessarily the name of the underlying repo. So you can say, you can see that, we can just simply model this Sky function as a bunch of sort of simple messages. And there's another one, like, hey, please give me the contents of this specific repo. I want to have the contents of rules go. That's also implemented as a Sky function. So you just give it a repo name, and then what happens is you sort of get like one of those storage references as a result, right? So what I explained, like that graph-based storage that why is he talking about graph-based storage so long? Wasted 10 minutes of my life. Well, that's because, it's actually integrated as part of my sort of SkyFrame function where, a Sky function can just yield massive amounts of data. And this differs from Bazel because Bazel might also have like a repo function, like, hey, please give me the contents of that thing. But Bazel, all Bazel does is then write it to disk and then give the path name to that thing, right? And then you sort of have to hope that you don't accidentally go into that directory and start editing files and sort of corrupt it. In this case, it's actually like you sort of get an immutable Merkle tree to that directory back, right? Yeah. So a nice advantage of this model is also like, currently in Bazel, if you change the patches on the repo, right? Bazel will just destroy that entire repo and re-download it. And then if you added the patches on that repo again, or you're doing like undoing that, you're switching back to the original code, and Bazel needs to do it again because half of its state is in memory and half of its state is on disk. But with this, it just becomes trivial, right? The Merkle tree is already there in storage, and the only thing we need to do is like, flip out a reference to go from one repo to the other. Yeah. So, the nice thing is we're sort of like embracing these sort of Sky functions. So that also means that sort of Bonanza has stack traces based on that, right? So normally whenever you run Bazel and you've got a typo somewhere in the build file, it will only say like, oh yeah, there's a typo in this file, or I tried to, something filled in this rule, but then you have no idea like why it was even parsing that build file in the first place, right? What made it consider that? And in this case, we're actually showing it as a stack trace, which we can do because we can just show the Sky function. So the trace at the top is at the sort of analysis level, the SkyFrame level, and then the trace at the bottom is at the starlark level, right? It's two stack traces. So demo. So this is not my laptop. So fortunately, I did prepare. I have like a video, and this is like, you folks know Buildbarn, right? I'm really bad at making UIs. So this is also like a video of. So me trying to sort of like, hey, let's kick off a build of BB storage. And then right now, because I'm really bad at UIs, the only thing you see is like it's going through all these Sky functions, right? Essentially, and running them. So you can see it's, hey, let's download protobuf, right? Because it was being referenced by something in Bazel mod. Oh yeah, apparently we need a JSONet. So we're also just downloading this. Yeah, and this video just goes on for 6 minutes. So it's
let's watch it.
Yeah, and that's because it's all just still single threaded, sort of, right? I'm just essentially doing like a Bazel -J1 because -J is not yet supported. That's one reason. But also because especially during development, right? It's really annoying if it's like -J500. It's 500 plane crashes in parallel. That's what can happen. So what's pretty cool about this is like, I can sort of spoil the ending. Let's spoil the ending. It's actually capable of like analyzing huge parts of the BB storage repo, and it's actually capable of even analyzing like /cmd/BB storage, which means that it's like running all the starlark code for rules go, getting through it, running like a whole bunch of code also for rules OCI. I don't know, downloading stuff from Bazel Central Registry, doing minimal version selection. It's essentially there, right? So unfortunately, it can't, here, this is interesting. You see all these action results. Now it's actually running actions. And those are like, that's repo rules that it was running, all via remote execution, right? And in a bit, you'll also see these action results flying by. And then right after it says like, oh, now I've got this Go repo and I can analyze that. So that was actually like go get blah running via remote execution on the worker. Yeah, see that might be these. So that's it basically. I've made a Bazel clone. Are there any questions? Maybe it's good to answer a question while we go around. Yeah. Okay, I see one hand being raised.
My first question is not a question, but a statement that's amazing. Really amazing. And very exciting to see the amount of progress you've made on it. I mean, there's a bunch of things, I won't occupy the mic forever, but one thing that occurred to me in your description of repository rules is, of course, repo rules are different from actions in that they don't know their inputs until they're later discovered. And so repo rules have this restart behavior where it says, oh, oops, I just discovered partway through evaluation, I didn't have this label, and now I'm gonna start from the beginning because I don't know what that might have done. Did you have to model that, or do you have a way around that?
That's a pretty good one. So indeed, so the restarts of repo rules, they fortunately never happen as part of an execute statement, right? It's always in between the execute statement. So what's happening is, it's not different from how sort of Skyframe restarts work, where it runs it, and then it discovers that something is missing, so it will stop running that. But then the second time it runs, it will go through the repo rule really quickly because all of those initial parts, it can sort of get hits on that, right? It's essentially in memory, there's like a dict that caches like for this sky function, you're supposed to get this sky value, right? So when executing a repo rule, you might see like a relatively high number of restarts compared to like other parts, but the overhead isn't huge. That's all I want to say, right? It's not unnecessarily rerunning stuff on workers. That's not what's happening, right? There's only some rerunning of Starlark code that happens. Yeah. And also one of the things that I'm not implementing yet is, Go's concurrency model is all pretty good. So instead of having like, you run a Sky function, discover that like a prerequisite isn't present, now we just terminate that thing and then run the prerequisites. We could also leave that thing running in a Go routine, right? And then sort of essentially just suspend it. And then once that prerequisite has been, run, that we then let it continue to run. So you'll have fewer restarts. Yeah, you just uses a bit more memory at that point. See, it's really slow. It's needs to be optimized. Oh yeah, but now it's awesome. You can actually see that like it went through rules proto, here AppStyle, you see it running in there. Oh man.
Maybe this should be a pre-built proto C.
Yeah.
Yeah. So another question from a practical point of view, people want to use Nix and Bazel at the same time, and historically the main thing preventing that from working is that the Nix store insists on using absolute paths, and now that your repository rules are guaranteed to run in an environment where you control the absolute paths, it seems like maybe rules Nix would work here where it doesn't work in Bazel.
Yeah, and it would get sort of centrally cached as well, right? So I've never used Nix, so you can be the lucky person to test this.
There will be a bunch of people eager to try that. Last question for me at least, the analyzer storage that you showed.
So the persistency, I have to sort of make one clear. Like this analysis stuff, I haven't implemented the persistency in the cache lookups for it yet. It's writing it into storage, but not looking it up properly. So carry on.
Okay, yeah, I mean, I'm sure that
missing features.
That also means that another follow missing feature, I assume, is that graph be versioned so that you don't have to reperform analysis from scratch after there's code changes, or do you naturally get that by virtue of the keys being stable?
The latter, right? So yeah, the idea is that this is going to be like cache lookups based on that, just similar to how an action cache works for remote execution. With a bunch of planned optimizations that is actually capable of doing a single cache lookup and then get a huge part of the build graph sort of return immediately. Like, hey, I don't need to analyze anything under rules Go because I've noticed that the rules Go source tree is the same as it was before. So let me just reuse a large part.
Can you help a poor fool who's only read up in build systems a la carte until they started writing Haskell? Does this need to be a restarting scheduler? I know one of the big advantages of Buck 2 is we now introduce dynamic dependencies, something that's a scary word in Bazel. If we're looking to truly transcend Bazel in the future, is this something that could even have Bazel as a subset of its API and we can include dynamic dependencies? I'm getting moons in my eyes right here. I'm seeing the future here. Help me out.
Yeah, so that's a really good question. So the reason you need the restarts is that it might sometimes be prohibitively expensive to keep everything in memory, right? It shouldn't be the case that like, ideally, you don't do any restarts at all. You suspend everything. Like, oh crap, I now need to know the SHA-SUM of the contents of this file, right? And you then pause the thing, go look up the contents of the file, and then return that. But the problem is with stuff like Bazel that that queue of stuff that you need to do, or like the list of everything that's getting suspended, suddenly starts to use a lot of memory and eats up all your RAM, right? So the restart feature, like the act of terminating a function prematurely and then later rerunning it, that should be done ideally only when we're sort of running out of resources, running out of memory. That's the idea. So right now I always do it, because this is all a lot of attention, right? But in the end, indeed, it should be the case that we only do actual restarts when resources don't permit us keeping it in memory. Yeah.
Thank you.
Any other questions? Oh, here, like the final frame of the video went black. So, but here at the very end, and I'll try to pause. Yeah, I managed to pause it. You saw that, like, okay, now I managed to configure this package in the build or this label, and now this and this and this and this and this. Ergo, I managed to configure BB storage. And now, normally in Bazel, prior to completion is the thing, the guide function that then actually builds the thing. But this is still implemented as a no-op and just says like, yeah, I'm fine just configuring it, and it terminates, right? So the Starlark part is done. It's just that the GNU make part of this isn't finished yet, that it actually runs stuff.
I think I must have missed something. In the answer to the previous question, I didn't catch how the restarts enable or don't enable dynamic dependencies. So this is the idea that the the results of previous executions influence the shape of the action graph, right?
So SkyFrame is inherently a system that works with dynamic dependencies, right? The entire idea behind like a system like SkyFrame is that you run a function, and for that function, you don't necessarily know the prerequisites of it, right? As part of that function, you can call into what they call an environment, and you can sort of give it a sky key, like now I need this specific thing, based on the attributes that were provided to this function, I need to SHA-SUM of this file. Based on this build file, I now need to evaluate glob **/food, right? Because, for example, we don't, or nowhere, when you have a Bazel project, you never have to specify the dependencies of a build file, right? Nowhere do you need to say like, oh wait, this build file over here, it does a glob **/foo, so it depends on this directory to compute the glob, right? So SkyFrame is inherently a system for, doing dynamic dependency discovery, right? Because you start to parse the build file, and as part of doing that, you discover like, oh no, now I need to sort of do a glob expansion that depends on file system contents, right?
So if an analysis input required an action output, that would naturally work here.
Yeah. Yeah, it could work, right? It's just that the Starlark API of Bazel doesn't allow it. And I want to make it Bazel compatible, so I also don't allow it.
It would be a superset.
Yeah.
Yeah, so I have a question. So in Bazel, there exists quite a bit that's implemented natively in Java.
Oh yeah.
Could you elaborate a little bit on how you deal with the things which are built in?
Oh yeah, it's okay. That's a really good question. Before I answer that question, I forgot I wanted to sort of there is still like a final slide past this one that I want to show, and then I'll answer your question. Help wanted, right? I need more people helping out with this. I can't do this on my own. Anyway, to answer your question, which was how do we deal with writing everything in Starlark? So first of all, the Bazel team is already working on Starlarkifying a lot of stuff, right? So in Bazel 8, it's actually the case that a lot of the C++, Java parts, whatever, are written in Starlark. What I've done is I've simply just mirrored that directory into the Bonanza source tree, and I'm using that as well. Unfortunately, that does depend on some features that are currently in Bazel still written in Java, right? It calls into sort of integrated helper functions, etc. So what I've done, and this system has internet access, I assume. So I can just go to github.com/buildbarn/bonanza. So there is this Starlark built-in score file. And this is sort of like stuff that I implemented that sort of gets preloaded before it even tries to, like, before parsing an arbitrary .bzl file, but even before parsing like the stuff that the Google developers wrote. So in here are like Starlark implementations for like a whole bunch of stuff, right? So are you folks interested in seeing an implementation of default info?
Mm-hmm.
Well, there you go. So what about, what is it? File group. That's an interesting one, right? Okay, here's an implementation of file group. Oh yeah, and oh, general. Yeah, so this is still like a bit bogus. But a config setting, constraint setting, see, these are all written in Starlark. General licenses. Oh yeah, it's just a placeholder. Platform, right? That's also a rule in my case. See, so this is like really funny. It's like all this stuff that you sort of take for granted or assume like this needs to be implemented in Java. No, not really. You can just sort of write it in Starlark if you want to. Yeah. Did that sort of answer your question?
Oh yeah, that's really amazing.
Yeah. Yeah, so one thing that's also like related to this, Bazel has something called fragments. Who knows what fragments are? Oh, one person, yeah. So there is this thing in Bazel where you can say ctx.fragments.blah, right? For example, ctx.fragments.cpp.compilation mode or something like that. And then it gives you back a string dbg or fast build or something like that. That's all written in Java right now in Bazel. But what I did in my implementation is sort of somewhat funnier. So first of all, here in Bazel tools, there's this new directory, which I call command line option. And inside of it are essentially just skylib common settings. So for example, compilation mode is just a string flag, right? I didn't need to write any sort of Go code to get this working. And then in ctx.fragments, I wrote this sort of custom provider, which I call like a fragment info. And that thing basically just gathers all the command line options and exposes that through here. And this is, if you say ctx.fragments.blah, it doesn't go through a whole bunch of Java code. It goes through all sorts of stuff written in Starlark. So the goal is really to sort of have as little as possible actually part of the Go implementation. As much of it should just go in Starlark as possible. Yeah. My concern is that like when people leave this room, that people have even more questions.
I might have missed it at the beginning, but in what ways is this a superset? And in which ways is this a violation of the existing remote base execution API or protocol?
So it's completely different, right?
Great.
It's a subser set. I don't know. It's inspired by the remote execution protocol.
I figured that was the case. I wanted to be sure. And now I'm sure.
Yeah. So, you know, where this might have come from, so over the last couple of years, I've tried pushing for an RAV3, you know, because some of the ideas that went in here, those were also the ones that I actually wanted to sort of propose that we get an RAV3, like the ability to store arbitrary graphs, right? Instead of just like directories and files. This is just like a generic graph storage, right? Those were all sorts of things I wanted to get in there, but apparently the appetite sort of wasn't sort of high enough. Right? That one thing this also depends on is, for example, you know, to make the repo rules run efficiently, having a proper symmetry in the protocol between input directories and output directories. There's a weird thing in RAV2 where the schema of input directories and output directories is different. So you can't easily yield a directory and then by reference say like, okay, now you worker, other worker, go use this as an input read. And this is something that you need to run repo rules efficiently, right? So those are all sorts of things I had to sort of fix. Yeah, but you know, 0% chance that the remote API working group is, you know, interested in fixing this in the short term. Yeah. But you know, if the working group, you know, decide to do like 180-degree turnaround and think like, hey, we do want to have an RAV3, I'm still available, right? It's just that they likely don't want to.
Do you have a sense yet of what is the limitation of how compatible this can be with Bazel? Like 100% of the time, Bonanza Bazel will behave like Bazel one day, or 100% is not feasible?
Yeah, it's a really good question. So like 100%, truly 100% will likely be impossible. So for example, one of the things I didn't mention, but if you sort of go to BB storage, I can show you like there's this Bonanza branch, and this is a branch you currently need to check out to build BB storage with Bonanza, right? I had to make some local changes. And one of them, for example, like the biggest API violation is that platform is different, right? Instead of platform properties, you now need to give in an X24519 pub key, because those keys are being used for the routing, right? Workers identify themselves by a pub key and not by OS equals Linux and whatever, right? Which is pretty great. But that means that it is incompatible with, right? And this is just one example, but there are like some slight things where I had to be sort of somewhat liberal with how I implement it. But you know, the hope is 90+%. I don't know how you can measure it, but yeah, 95%.
And I assume that that doesn't include in scope the 750 command line options.
Yeah, that's indeed, there will, so my goal is to sort of focus on a sane subset. But the nice thing is that like what I showed previously, this command line option directory, I have it here. This build file is not actually part of the Bonanza server side. It's actually the case that the client needs to like upload it. So what I hint from you folks is that -- config equals Bonanza has some flags in there that says like, oh, here's like a directory with Bazel tools, and you need to give that, right? So fortunately, you know, whether I can support all flags, no, but fortunately it's all on the client side. The client side can basically determine which flags exist. If a flag is missing or something like that, they can always just add this flag to the command line option directory themselves, and then override the Bazel tools dependency, sort of, and say like, hey, this is a copy of Bazel tools you need to use that has this flag.
Right, but of course, a lot of those flags are meant to influence the behavior of things that you've implemented in Go, and so I assume that those flags wouldn't function the way you expect.
So yeah, so some flags like -J or something, those will obviously need to be, you know, written natively and caught by this implementation, but -- platform, even that is just a flag that that can be implemented as part of this. Yeah. So yeah, supporting everything is impossible, but we can make a huge part of it work.
I'm sorry, I have a million questions. Do you persist like the persistent worker spawn strategy? Obviously, there's such a thing as remote persistent workers, which Buildbarn doesn't have yet in BB remote execution. Is that like on your? Do you have any thought about it?
No. As in, if someone wants to think about it and implement it, great, right? Yeah, but I haven't given it any thought. I'm too busy getting this to work at this point. Yeah. Oh yeah, sure.
You mentioned several times we or I. That's true. What is the plan for this, or who has been working on this? Is it your side project? Is it sponsored by your company?
So I've got some blue blood in me, and that's why I sometimes refer to myself in the we form.
All right, Your Highness, thank you very much.